Welcome to our lesson, introducing the concept of a variable. If you are new to algebra, then one of the things that can sometimes be the most intimidating thing about starting your algebra journey is the fact that you start to see all kinds of letters tossed in with your numbers. So it's important that we understand and establish at the beginning, what is a variable? How does it behave? What can you do with it? So first off, we want to define what a variable is. A variable is a letter used to represent an unknown number, potentially a number that could be changing in value, hence the term variable. So you think of the word variable, you might think of the word vary. And so it's a letter that's used to represent something that's unknown. Now, later on in math, much later on, you will see some letters that are used to represent known values. Okay, and we rarely will use those letters as variables early on in math because the people that know where your math is going know that it's going to go there, and so we don't use those. And it's important to distinguish those from a variable, that a variable is something that is currently unknown or possibly might change. Probably the most common variable that's used in algebra is the letter X. You might have seen some internet memes that talk about X's and finding your X. Y is also extremely common in algebra. Others that are common, you might see Z. Okay, and just for reference for my videos, I always cross my Z's. I don't always do my twos the same way. So like you can have your loopy two and your not loopy two, and mine will do both of those, but my Z's will always be crossed. Early in algebra and sometimes in pre-algebra, you'll see N used a lot for your variable because for students that are brand new to the concept, N might represent the word number. Now, if the variable represents a specific quantity, that is something that's being measured. So my favorite kinds of problems in algebra are word problems where we actually use the math to measure things. We will often use a letter that reminds us of that quantity. So a really common variable is the letter T for time. So if you're doing a problem and time is one of your unknowns, okay, or something that might be changing, then you might use a T for that. You might see a V for volume or possibly velocity. Okay, so all kinds of cool things that you might see for your variables, but pretty much a variable represents some unknown number. What is an algebraic expression? So it's really important that we nail down what an algebraic expression is, because in not too long in your algebra journey, you will encounter algebraic equations, and they are not quite the same thing as algebraic expressions. And it's something that my students will often get flip-flopped in their head, and I teach like upper level math. So an algebraic expression is a collection of numbers and variables, usually variables, related by operations. And if you're not sure what operations are, go ahead and check out my previous video on operations. So operations, typically in math, we start out with adding, subtracting, multiplying, and dividing, but we will add a lot of other operations to those ones. So examples of algebraic expressions, you might see x plus 10, for example. The x is the variable, the 10 is a number. We'll call that a constant because 10 is just 10, and the operation involved there is adding. You might see something like 8t. Now I'm going to pause on this one for a little bit because there's some things we need to know about that. What that means is 8 times t. Okay, so if you see a number just right next to a letter there with no operator indicated, the implied operation there is multiplication. Okay, so it is implied multiplication. And as soon as we get to solving equations, that is something you're going to want to know. Now, there is a name for that. 8 is called the, and I'll go ahead and put this in quotation marks, coefficient. Okay, that's Coefficient. Okay, my E there is the greatest. So 8 is called the coefficient. That's kind of a big word that just means the number multiplying the variable. Okay, sometimes my students will call it the number out front, but it is important to know that it is multiplying. Okay, and you might see coefficient used if it's operating, say, something like a square root. So that's a really, really important thing to know, again, for when we get to equations. Now, you could also see something like this, 3n minus 4, and that means it's possible to have more than one operator. To have more than one operator. So that has multiplication, 3 times n, and then subtracting a 4. And you could see something like this. We'll do another one, like 20y divided by 5. Now, that is currently unsimplified, and we're not going to worry about simplifying it. But you might be thinking from some of your grade school math, well, that looks like division there. So 20 divided by 5 is 4, and that indeed would be a simplified version of that expression. Now, a really important vocab word to know. Okay, so this lesson might seem a little basic, but there's a lot of really, really, really important vocabulary. What does it mean to evaluate an expression? So one of the first skills we learn is evaluating expression. To evaluate means to determine the numerical value of something. And I'm going to start that because you will see that direction in a lot of places. Okay, it'll say evaluate this, and it does not go away in your math journey. Okay, you'll see evaluate, evaluate, evaluate. So when you see the word to evaluate, that can be different from solve, graph, simplify, some of the other directional words that you might be given. So to evaluate means to determine the numerical value. So here we have a problem. Evaluate, here's our algebraic expression, 2x minus 3y, 4x is equal to 3, and y is equal to 1. So what that means is that the value of x, we are being told, is 3. So we're going to take out the x, and we're going to substitute the x with the 3. Now remember that that is multiplication right there in between the 2 and the x. So when I take out the x and replace it with the 3, I need to indicate multiplication. I opted to do that with parentheses. So if that's a little bit confusing, check out my video on operations in algebra. Somebody else might opt to use a different symbol. So I'll go ahead and use a different symbol over here. We're going to take out that y and replace that y with a 1. And so you might see like the little dot there for multiplication. Regardless of what indicator you want to use for the multiplication, you do need to remember that that is indeed multiplication. 2 times 3 is 6. And 3 times 1 is 3, and 6 minus 3 is 3. Notice that I am working top to bottom, okay? So that is how we format our work in algebra. We do not do equals and keep going off to the right, okay? I recently did a lesson in my class at school where we were doing logarithms, and I wrote top to bottom on about a dozen homework assignments because my students were like stringing their work across the page from left to right. So we work from top to bottom. And so the answer to that, we'll go ahead and box that in, is 3. So a key idea later on is that a variable might change values. For example, if the variable represents time in a problem, then we may need to know a value for different values of time, like say how much money someone has after 1 month, 2 months, or a year. And so you might have an algebraic expression that has like a t in it, and you would need to figure out the value for multiple possible values for that variable. So here we have evaluate 2t minus 1 for t equals 1, t equals 2, and t equals 3. It's actually 3 different problems. So I'm going to start this by doing 2t minus 1. So I'm going to copy the expression, and then we'll plug in a 1 for the t. So that's our first problem there. 2 times 1 is 2, and 2 minus 1 is 1 for a value of 1. Second problem, I'm going to copy that down again. And again, notice that I'm working top to bottom. This time I will plug in a 2 for the t. 2 times 2 is 4, and 4 minus 1 is 3. One more time. 2t minus 1. 2, now this time we'll be plugging in the t is equal to 3. Minus 1, 2 times 3 is 6. And 6 minus 1 is 5. Now, before I move on from this, note the pattern there, okay? That is what algebra is all about. So every time I increased the t by 1, so I went from 1 to 2 and then from 2 to 3, the y value, or I'm sorry, the output increased by 2. And so we have like some odd numbers going on down here. Okay, just make a note of that because algebra is going to be all about patterns. And so if you change your value that you're plugging in for the variable by some kind of predictable way, like say 1, 2, 3, 4, you should notice that the evaluation of the expression also changes by a predictable pattern. In this case, the odd numbers. So where do we commonly see variables and expressions? Someplace that you've likely seen them before now is in formulas. So a couple of examples of formulas, say we'll do like the area of a rectangle, and the area of a rectangle is the length of the rectangle times the width. Now, those are what are known as the dimensions. So sometimes you might have heard that the length is long end, but it honestly doesn't matter. When we're talking about length and width, what we mean are the measurements of the sides, and a blanket word for that is the dimensions. I teach an engineering class where we do a lot of geometry work with a lot of different shapes, and a lot of my students don't know what the dimensions are when we talk about, say, dimensioning something. So the dimensions may be, say, length and width, and what we mean there are the measurements of the lengths of the sides. Another common formula is this one. So this is a formula for distance, and the R stands for the rate, okay? And by that we mean how fast times the time, which is how long. So if you would like to know how far someone has gone, you would take how fast they are going times how long they are going. So I'm a runner, and I might set out. So earlier today I did an 8-mile run, and someone might ask me, well, how long will that take you? Well, it depends on how fast I go, and I'm not always going the same speed. So sometimes I might have more energy, I might run faster, and then I might run slower. And so you really get that idea that things might be variables. So here's an example problem. Find the area of a rectangle with length 5 feet and width 2 feet. So one of my high school teachers had a pattern that he liked us to use when it came to solving problems like this. And he would tell us to do this, list the givens, okay, first. So that would be just creating a list of what we know from the problem. So we might say L is equal to 5 feet. L represents the length, and we would just indicate that we understood that the length was 5 feet. The width is 2 feet. Okay, that's listing the givens. Then he would make us list the formula that we planned to use. So area is length times width, and only then were we allowed to plug in the numbers. So length is 5, width is 2. Again, notice I'm working top to bottom. 5 times 2 is 10, and the units on that are feet squared. Now, I don't want to get into why the units are feet squared right now, because we need to cover a little bit about exponents first, but that's coming up in a future lesson, so you can click on over to that video if you'd like to see the why behind that. And so we have area is equal to 10 feet squared, and then we might circle or box our answer. Notice again that top to bottom work. Okay, and the reason we do it top to bottom is that if you kind of look at the structure here, if somebody says, well, where did you get that 5 from? Where did that 5 come from? Look right above it. 5 was substituted in for the L. Somebody might say, well, where did you get a 10 from? Well, look right above it. The 10 came from 5 times 2. If you stretch your work out from side to side, you don't really see that pattern well. Now, last note, sometimes you may see different vocabulary, such as a base and height instead of length and width. This does not change the concepts, only the letters that are used to represent the dimensions of the rectangle. So sometimes you might see the area of a rectangle is base times height. Those are just different words that are used to represent the same dimensions. So you might see base times height instead of length times width. So just don't let that throw you if you see it. Okay, so for some practice problems, click the link above or the link in the description box to practice the concepts covered in this video.